Hello and welcome to this video, the second in our series on the highly respected QCD system of KPIs for business performance management. My name is Carl and I'm a business improvement greybeard. In this video we'll have a quick refresh on the scope and logic behind the QCD system before exploring each of the QCD metrics in detail, looking at how each one is calculated and the circumstances that are likely to indicate which metrics are going to prove most important to your own local deployment.
Welcome to the Greybeard Academy, providing knowledge and advice to business leaders and business improvement specialists around the world.
The basic system of the QCD system is to focus on the business activity as a process. However, this process could be at pretty much any level within the business, from the operation of the entire business site or the activities of a specific department, area or cell. For the area we're considering, the process would represent those things that the local team do in order to satisfy their business needs, so the scope of their responsibilities. At the highest level of consideration, we can think of the process to be made up of its effectiveness in the delivery of its outputs to satisfy customer needs and its efficiency, which is measured in terms of the resource costs that are required in order to satisfy those same business needs. Within the QCD system, the effectiveness of the process is then considered in terms of its quality performance and its delivery performance. And that's performance associated with those delivered outputs. The measures of efficiency in the operation of the process are generally considered to be time-based, and these look at the level of efficiency or cost effectiveness we achieve with each of the resources that we deploy in order to satisfy business needs. Those resource categories being our people, the materials we use, the equipment, and then the site overhead, so the cost of the working area. So starting off with the effectiveness performance metrics, the first of these would be the measurement of our quality performance. Now this within the QCD system is a relatively straightforward metric. And what we measure here is the percentage of non-right first time. We calculate that by determining the total number of outputs that we've delivered, be those component parts or service transactions. That goes at the bottom of the equation, and on the top of the equation we identify how many of those outputs were defective. And defective here would mean not meeting the customer requirement or the specification. So we divide the number of defectives by the total number of delivered outputs. We multiply that by 100 to give us a percentage score of non-right first time. The second of the effectiveness performance metrics is the measurement of delivery performance, and that's measured in terms of delivery schedule achievement. That's slightly different than the measurement of quality in that we measure this at the order line item level rather than the individual component level. It's calculated by identifying the total number of order line items that we've delivered and also identifying the number of those that were incorrect. An incorrect delivery here would represent any delivery that is either late to the customer requirement date or incomplete, so carrying shortages. We make the calculation by subtracting the number of late deliveries from the total number of deliveries and then dividing again by the total number of delivery line items. We multiply that result by 100 again to give us a percentage score of the delivery schedule achievement from our process. Before we move off the effectiveness performance metrics, it's worthwhile making a couple of points here about their significance. The measurement of delivery and quality performance is our last chance to identify performance concerns before they've actually impacted on our customers. It's often within business that companies will actually rely on their customers to get that feedback on performance. So often companies will measure quality performance based on the returns that they receive, so either customer complaints or rejected parts. Now the problem there is obviously we've already caused some damage to that, to our reputation and to that relationship. Another alternative might be to try and measure the performance of those deliveries or the quality of our parts before they leave the site. And we could do that either by measuring all the components, if that's practical and affordable, or by using an appropriate sample size to get feedback on the quality and delivery performance of our area. Okay, moving on to the efficiency performance metrics. The first of the areas of resource that we would want to measure the efficiency of is our people resource. And generally, the people resource and or the equipment resource efficiencies would be likely to be the most significant and highest importance within a company. We can measure our people effectiveness through using a metric called people productivity. Again, this is quite a simple metric. We're just identifying the quantity of good outputs that we've produced, be those correct parts or correct service transactions, and we're dividing that by the total number of hours worked, that total number being the sum of all the hours worked by all the staff in the delivery of those outputs. The metric then is determined in terms of number of products or service transactions per hour. Staying on the topic of efficiency measurement, there's an alternative metric that we can use for the measure of people efficiency, and that is to measure our value added per person. We can use it as an either or an and to the people productivity that we just discussed, dependent on our business needs. We calculate the value added per person by determining the annual sales turnover, so the value of the product or service that's been sold from our area, and we subtract from that the total input costs that were required in order to achieve those sales. So those would typically be made up of any raw material or subcontract activities that we've had to spend cost on in order to support those sales. Once we've determined that amount of value that's been added, we divide that by the number of people that have been directly involved in the delivery of that production or service activity. So the units of the value added per person would be in currency units, so maybe in pounds, dollars or euros, divided by, per person per annum. The next area of efficiency performance measurement is that which would use to determine the cost effectiveness of our plant or equipment. And that metric is called overall equipment effectiveness. Overall equipment effectiveness is an extremely tough metric because it's made up of a compound of three separate elements. For each piece of equipment that we're monitoring here, we'd identify the level of availability of that equipment. We'd multiply that by the level of performance that's being achieved in terms of its operating rate. And then finally, we'd multiply that again by the level of quality performance that's been achieved from in its outputs. The availability is the amount of actual availability as a proportion of planned activity. So any time that we've lost due to unplanned breakdowns, unplanned maintenance or changeovers or setup would come off that total planned availability. So we're determining a proportion there, or a fraction of time that the piece of plant was available. The second element is to look at the performance. So a piece of plant may have a certain performance rate, it should operate at a certain speed. Again, any issue that are detracting from that operating speed due to operator unfamiliarity, lack of experience, or because of deterioration of the plant and equipment, which results in it having to run at a slower rate, would all reduce that performance rate. And then finally, we'd look at the quality performance achieved from the process. So if we have a certain level of non-right first time components, those would again detract from the overall performance. Anytime when we're multiplying three fractions, obviously it's going to be a relatively low level of performance. A typical level of overall equipment effectiveness would be in the 40 to 60% bracket. I have seen examples where it's in single figures. World class is supposed to be around the 85%, although most times when I've seen companies with those levels of performance, there has been some issues with the way that they've been measuring one or two of those metrics. So by way of illustration, to better understand this calculation of OEE, we've got an example here on the screen. So in this example, we have a piece of plant and equipment that's been scheduled to produce or designed to produce around 1,000 parts per day. And that's based on a 10-hour working day for this piece of equipment. Applying the three levels of the OEE calculation. Now in this example, this piece of plant and equipment has suffered some breakdowns and spent some time on changeover activities during this day. And so we've lost some of that availability time. In fact, in the example, we've lost 50% of the time. And so our 1,000 capacity has already been reduced to a maximum capacity of 500 components. Applying the second level of the OEE calculation, the piece of plant has then also not been operating at full rate. So because of both machine condition problems and because we have a new operator on the piece of plant and equipment, it's had to operate at a much slower production rate than it should have been working at. And again, in this case, we're down to a 50% operating rate. So now our 500 has reduced to 250 components of capacity. And applying the final level of the OEE calculation, the quality element, in this example, only 50% of the parts that were produced by this process were right first time. The other 50% required some rework or were scrap and were lost from that capacity calculation. So again, that's a 50% production. And so our initial 1,000 components of capacity was reduced to a 500, then reduced by half to 250, and by half again to 125. So in this example, the overall equipment effectiveness is 12.5%. And that illustrates just how easy it is, so how brutal the calculation is in OEE, and how easy it is to lose some of that maximum potential yield. On the positive side though, it does show just how much capability is often available when we deploy and use OEE to drive improvements in equipment efficiency. The next area of efficiency measure would look at our material investment, and that's calculated through looking at something called stock turns. Again, a relatively easy calculation, although the collection of the data necessary for this calculation might be a bit involved. The calculation is taking again the annual turnover, so the total annual sales turnover from our area, and it's dividing that by the total investment in raw materials, work in progress and finished goods. And when we calculate that, we come up with a factor. And that factor of stock turns will often be in the range of 2 to 4 within businesses. Again, a world-class level of stock turns would be around 10. Now, although there'd be a fair bit of work involved in collecting this data, normally it's already been collected. So these are figures that are normally available through our financial accounts. The final area of resource efficiency that we'd consider within the QCD system is floor space utilisation. Now, this is one that can be extremely important, but quite often would be the least often used of the QCD metrics. I have had examples where companies have been growing their production volumes and at the same time have been extremely constrained in terms of space. They've been in positions where they've been contemplating moving to more expensive and larger factories. In circumstances like that, this can be a critically important measure. So the way that we calculate the floor space utilisation is by, again, using that annualised sales turnover. So the complete value of sales turnover from our area, and we divide that by the amount of floor space that we occupy. So the number of metres squared of working area that we've occupied. So again, that gives us a metric in terms of a currency, but this time per square metre per annum. Within the previous video on QCD management, we did mention a recommended enhancement, which would be the adoption of the measurement of lead time. And this is a really strong supplement to that QCD performance management system. It's a very simple calculation. We're just measuring the total time to complete our process activities. Dependent on where within the business we're applying these performance metrics, there's a number of ways that we could measure that. But those would look at what do we consider to be within scope of our lead time. So if we're looking at the business level, we may well measure the total time taken from order receipt to the delivery of the parts to satisfy that order. If we're working in a lower level production area or department, we'd probably measure the time taken from the launch of a particular work activity through to its completion. The units we'd use there would be entirely dependent on the nature of the activity. You know, if we're involved in, say, shipbuilding, we might be measuring in weeks or months. If we've got a transaction that's exceedingly quick, we may be measuring in seconds or minutes. So where to start with a QCD performance metric deployment? By far the highest significance area of the performance metrics are those that centre on the effectiveness of our process. So we generally start with the deployment of quality and delivery performance measurement. And that's because, as mentioned earlier, these are the things that can impact directly on our customers and our customers' opinion of us, and potentially threaten business continuity. When we're looking at the efficiency performance metrics, we could deploy all 4 resource area performance measures. It's more likely that we'd identify the 2 or 3 metrics that matter most to our area. Generally, the people or the equipment measures are typically the most significant, but dependent on circumstances, it might be critically important to a particular business, either to reduce the space or maintain the space that we occupy, and sometimes also there's a big opportunity with the material investment. This would typically be a one-off potential benefit, but if we do find that our stock turns value is extremely low, we may find that we've got a potential windfall there of releasing quite a lot of cash that might be tied up in our raw material work in progress or finished goods. In terms of how we should go about deploying the performance metrics, we have a number of choices open to us. We could either establish the performance metrics electronically using Excel or another type of performance dashboard, Power BI perhaps, or we could produce all of our graphs and chart our performance manually. We shouldn't be afraid of using the manual graphs. There are a certain number of very genuine advantages to doing things manually. Not the least of these is it helps very much with the credibility of the values that we establish. So if we're working in a particular team and we're introducing new metrics, the fact that we measure them locally, we count up the figures, we do the calculations, and then we plot the graphs manually, makes them a lot easier to understand and relate to. So we've got an example here on the screen where we monitor one of our performance metrics. In this case, it's the non-right first time performance, and then that would show how it would then lead us into an ability to be able to analyze and improve the performance of that metric. Another option that we'd have is to establish local performance management boards, so having a KPI notice board. And within this notice board, we could display the ongoing performance of each of the metrics that we've deployed, and we could also on there capture our improvement activities, so showing the key elements of the analysis, the findings of that analysis, and the action plans and their progress management through to achieving performance improvement. So to summarise, the QCD management system and the QCD metrics are relatively simple to understand and deploy, but they provide a very strong holistic oversight of performance within our working area. They're able to be used in either service or manufacturing areas, and they're extremely effective in allowing us to understand our performance, understand why the performance is what it is, and then start that ball rolling in doing something about it. So I hope you found today's video useful and informative. We will be posting some further videos shortly. I think the next of these are likely to be on the topics of how to use these metrics to drive performance improvement. So how to go about taking a particular performance metric and starting to do that analysis, prioritization and action planning to drive your business improvement activities. Another video that we plan shortly would be focused on how to go about establishing a visual performance management system. So if you have aspirations to establish a local performance management board, some of these principles of visual performance management, I think you'll find extremely useful.
We do hope you found today's video interesting and informative. If you did, please click the like and subscribe buttons below. This really helps in getting our videos prioritized and found. Thank you and ciao, the Great Beard Academy.